Thanks very much, Jan. It's great to be here. It's a long way from the bassoon, I should note. And I wanted to take you on a bit of a journey today, in the same way that Darwin had his famous voyage of the Beagle, looking at what we can learn from evolution and how we can apply that into the world in which we live, digital marketing, conversion optimization, growth hacking, and whatnot. What I'm going to talk about today is embodied in a product we have, so I sort of let me apologize for that up front. We're the only guys doing this particular method. But my goal today is going to be to talk a little bit about the science of what we do and how we are approaching, really with a different body of math, the act of conversion optimization and what that might mean for how we think about our jobs and how we think about testing. When you look at the world of science, it's hard to think about a scientific achievement that has generated more change in our worldview than evolution. Some people might say, well, what about Newton's theory of mechanics, or what about Einstein's theory of relativity? And these, of course, were very important scientific achievements that talked about our place in the world. But evolution really speaks to who we are. Evolution created what we are. It created pretty much everything that we hold dear, our family, our animals, our gardens, all products of this of evolution, and the theory that Darwin himself created really from observing the patterns of multiple birds. And when you look around in the world, evolution is very much part of our mindset. The famous picture of the ascent of man is repeated many times. You'll see Darwin on the back of many a car. It's really part of our mind view. But what many people don't know, many of you may know, is that evolution is also one of the main branches of AI. Right? Artificial intelligence comes in many different forms, and there are many different classifications of artificial intelligence. This comes from a book by Pedro Domingos called The Master Algorithm. And each of these families essentially represents a different body of math, a different core family of algorithms that are used to create systems that can solve problems in ways like humans can, and also be capable of self-learning. And of course, deep learning is the one that's most popular these days. It's what's driving the current wave of interest in AI. Deep learning, neural networks, very powerful technology, very good for certain types of tasks, in particular perceptual tasks, speech recognition, Siri, voice recognition, understanding what's in a picture, or what dress looks like another dress, but not so great for optimizing, not so great for decision making. And evolutionary algorithms were created, or first, I guess, conceived of about 45 years ago by a mathematician named John Holland, who made the simple observation that while there are a countless number of DNA combinations, 2 to the 1.8 billion, right, this sort of staggering number, there's only 9 million plants and animals, and each of them is uniquely adapted, uniquely optimized for the niche that it sits in, whether it's in the water or the cities or the mountain or the ice. That's something about evolution, something about natural selection has been very efficient at producing optimal designs. And so Holland created the first theorem that's called schema theorem. This is the underlying theorem of genetic algorithms or evolutionary algorithms. There are many more enhancements to this, but what this theorem looks at essentially is how do good traits, how do good individual characteristics of a species or good design elements of a web page, you might think about it, how do those propagate across multiple generations? And what is the role of mutation in sort of driving change and making systems getting better? And by modeling evolution in this way, he then allowed these principles to be applied into the design of different things, originally applied back in the 70s into finance. And when you sort of drill down and reduce that equation, there's really 3 core concepts that are pretty simple to understand based on your knowledge of evolution. One is fitness, one is combination and mutation. And fitness is really just, what is your goal? If our goal is survival of the fittest, whatever we're designing, the fittest web page, the fittest trading system, the fittest radio antenna, what is fit? You have to define. That's the goal. So that's usually, in our world of conversion optimization, that's usually average revenues per user or conversion rate or engagement time or something like that. Combination is a notion says if you have two better than average designs, whether that's a design for a landing page or an email campaign or a racehorse, and you create children designs out of them, somehow you cross them over, breed them, or create children designs, some of those kids will be better. It's a way to climb a performance hill in conversion terms. And mutation in evolutionary thinking and evolutionary algorithms, just like in nature, it's a very important function that helps make sure that we're sort of we're trying all the angles. We're exploring all the corners of the potential space of possible ideas. So when you apply these techniques to design and you let evolution design things as opposed to humans, you can get some very different looking and very powerful designs. This is a famous example of a radio antenna designed by evolution for NASA. Now, this looks nothing like any human would ever design. In fact, when humans tried to design this antenna, they would create things that were very symmetrical. But let evolution do it. The fitness function in this case was its ability to receive radio waves, and the system just tried different versions, combined the ones that worked, and ended up with this sort of very intricate thing that looks like a bunch of bent paper clips. Similarly, we use evolution ourselves at Sentient to run a hedge fund, and while this is a very sort of complex list of rules, this is an example, a portion of a trading desk for our hedge fund. So we use evolution to evolve huge combinations of rule sets to trade stocks live and autonomously. And while this may not be easy to read, one thing that's interesting about evolution versus, say, machine learning is that it is, in fact, readable. It's not a black box. Evolution, the code of evolution is apparent for everyone to see. So if you're in the business of designing things and you're interested in AI, a lot of problems people have with AI is, I don't know how it gets the answers that it gets. But in the case of evolution, you're able to sort of trace the heritage of the design. So when we thought about what are areas where this might be, these kinds of evolutionary approaches might be applicable in business, we came upon conversion optimization because we felt that there's a real gap between what you're all being told you should do to succeed, which is test everything all the time in every aspect of your business, and the state of the existing technology. It's fine, we talked about this yesterday, it's fine if you're Amazon or Booking.com, who's up next. You have vast traffic, you can run thousands of A/B tests a year, but it's hard, you can't test on this scale if you don't have that kind of traffic. So what's someone to do? So we saw an opportunity to fix that, which is why we came out with the product Ascend, which is an optimization product, but it's not A/B. It uses AI to achieve the same things and sort of changes the game in optimization from a step-at-a-time A/B approach to a massively multivariate system where you create genes, you create ideas, you throw them into a population, and you see how that emerges. Now let me try to put this into statistical terms. The goal is to have AI that can create new designs. Right? How do we help create new, more effective, powerful web page, landing page, mobile app designs? And typically, the human approach is, you start with something that works, you make some changes, you test them, you keep the ones that work, and that you iterate. It's a very classic process. Hill climbing, right? So you climb your hill, you do your best, but sometimes you'll hit the top and you have to require a fresh start. I hear that a lot in testing. We optimize, now it's time for a redesign, right? And general AI, when you look at machine learning, it is actually very similar to the same process. With machine learning, the goal is how do I understand how to climb the hill? And machine learning uses something called gradient descent, not related to our product name, to essentially help you understand what's the relationship between inputs and outputs. In deep learning, you use neural networks to create these models. And in reinforcement learning, another type of AI, you're sort of trying guesses around each individual point on the hill. But that doesn't work that well for most things. And when you really think about the challenge of designing the perfect web page, it doesn't look, there's never a single hill, right? And there's never a single hill for a person. So this kind of one step at a time approach is very limited. It generally only finds the nearest hill. there's too many different possibilities, so just starting again and again won't always get you to where you're going. And then there's many different factors that influence conversion. It's a high dimensionality space, right? It could be the color, the flow, the layout, the headline, the image, the whatever, and different by person. So that just testing one thing at a time often is hard to show a big difference, and that's why so many of our tests are inconclusive, right? Because it's just not enough to show. So the sort of scientific answer to all this was, or one of them, is doing something called population search, where as opposed to testing one thing at a time, you test many different variables all at once in multiple candidates. And there's different traps that method can also create, but there's techniques around it, things like novelty search. So to put this in evolutionary terms, evolution is a form of this, right? It's rather than think of your website as a sequence of elements, we can think of it as an encoding of genes, individual elements on the web page. We can put those genes into different types of designs. We can test them, retain the good ones, throw away the bad ones, and then create another generation of designs, right, through evolution, using something called crossover. So you take that representation of that first design and combine it with the representation of the second design, the good ones, and two good parents will often create a better child. So that's sort of the science behind it. I know I'm moving through it quickly, but when you apply evolution to website testing, it creates a whole new opportunity to test at a scale you never thought possible. So if you take a page like this, just obviously a sample page, let's say you had 13 different changes that you wanted to attest, 2 to 4 values for each. There's actually 1.1 million, more than 1.1 million versions of this page. So it's not anything you're ever going to A/B test your way through. You could run a test on each of the individual 13 elements. That would take quite a long time for many different sites. And you would have no idea how these different elements combine, because in our traditional approach of A/B testing, we always assume that what happened before was the best thing to go with what we're testing next. It ignores interaction effects that are quite real. So with Ascend, we take a different approach. So you would put in your ideas. Let's say I want to try these 5 headlines, these 4 images, these 3 layouts, these 2 different flow combinations, whatever those changes are. And Ascend starts by creating an initial generation of designs. Each of those dots represents a design on that plane, if you would. And the size of the circle is the conversion rate. So you run a test, and instead of testing one design at a time, you test 10 or 20 at a time that represent different combinations of these individual elements that you're testing. And as soon as you can see which ones are better, right? Evolution relies on we're not running a full A/B test. If we're testing 20 different designs, we're looking for a certain amount of statistical strength to identify which of these designs are better or trending better. It's not definitive. And once we have that information, the system goes and creates children from those designs. It combines the traits of design A and design B to create 2 children. There's a second one behind there, ghosted, and so on and so forth. And then those designs, those evolved designs, that second generation, are tested. Once again, we look which are the best, and then go on and create additional children. And what happens when you take this parallel search approach to finding best designs is that you can essentially explore many more ideas all at once, and in your testing get to much better results much more quickly. When you can test multiple ideas, multiple genes, as opposed to with A/B testing, the chances that you'll have successful ideas that will lift your results is much higher. And so when we do evolutionary testing, somewhere between 80 and 90% of our tests do generate a statistical winner instead of the 15, 20, 25% that is standard in A/B testing. So let's take it back to that example of 1.1 million designs. And when you apply evolution, what makes evolution such a powerful technology is that you can solve that design problem. What's the best of those 1.1 million designs while only testing about 600 designs. So still quite a few, but in this case we would test 15 generations of 40 designs, and with each generation we would evolve to better designs and better designs and better designs. So in the space of about 600 tests, we could definitively solve what's the best combination out of those 1.1 million designs to achieve whatever your goal was, whatever that conversion rate goal was. So it's a tremendously efficient way to do it. Looking at one example that we did, just to sort of take you through, and we have many different case studies. So in this particular case, this company, which is Above Media, was interested in increasing the throughput on its form. Above Media is a publisher. They publish content about careers and education, and their goal is to get you to submit their name, and they'll sell your name to one of these training programs. And this page had been highly optimized over 2 years. They'd run many different A/B tests over the years on the content, on the layout, on the structure. But they had many different things they wanted to test. They had a huge backlog. So in this particular experiment, they entered 36 different potential values for 7 different elements on this page. So they wanted to test the words on this button here, the words in the banner, the colors here, the colors here, the color of the box, and then a couple different JavaScript effects. So in total, there are about 381,000 potential forms that were possible. And so using evolution, you can search through that space efficiently. So this animation will show the different designs that the system tried over various generations, in this case 4 generations of designs, to find what was ultimately the winner. And when you look at the winner versus the original, I think we'd all think that, yes, these are better words. It's better to choose something than to search for it. It's more empowering, and it's better to find something than to search for it. So these were the best words. But the colors no one anticipated. Like no one would have predicted or ever A/B tested their way to this particular result, which for whatever reason works 45% better than the original result. So in the space of 110 tests, all of which are automated by the artificial intelligence, just from the input of the ideas, you're able to conduct experiments of this scale and move the needle very aggressively in terms of how different businesses work. Now, this is this experiment broken down, and it's worth looking at. So each of these is a generation, right? And each of these lines is a different design that was tested. So in this evolutionary approach, we start by testing each single idea. So if you recall, there were about 36 different changes that they want to try, different colors, different words, or whatnot. So the system tests this, and we run through it. It's not a 95% confidence test. You can see that the error bars in almost all cases cross the control line. So none of these are statistically 95% better, right now in the traffic that we gave them than control. There were a few that were clearly worse. But once the system sees the information from this generation, it then takes the best parents and creates a new generation of designs that are essentially the children of that first generation designs. And you can start to see that things are getting better, that more designs are above the control line and further above the control line. And then after this generation was observed, a third generation of designs is created. And once again, we found what was ultimately the best design there, the 45% winner. And even more generations were above the fold. And in this case, the 4th generation was relatively flat. Now, typically, evolutions will run a little more than 4 generations. We'll run them for 6 to 8. And that's the time at which you really have gotten the most value, the highest increase in conversion over time. But this kind of approach, and again, this was all fully automated by the system. No one had to hand create these designs. We were able to find a much more significant winner, but also while doing the test, which took about, in this case, 7 weeks, we were up about 12% in terms of the overall results, because as evolution as it's looking for that best design, it's increasing the quality of most of the designs. So it's a very interesting approach and allows you to test many more things. So where are we going with this? The technology is, evolution doesn't just need to evolve website designs. It can evolve anything, right? And as noted before, we use this to evolve hedge funds. So what you're seeing here is a representation of what we think of as neuroevolution. And neuroevolution is the application of evolutionary algorithms to the design of deep learning networks, of neural networks. Neural networks are super powerful, as we discussed, in many types of problems. They're also really hard to build and architect. I heard our CTO estimated recently it's only 2,000 to 3,000 people in the world that are good at architecting, big, sophisticated deep learning networks. But using this technology, this allows us to then connect personalization with optimization. So it's something we call auto-segmentation. It's in beta now, so it's not shipping. But rather than run an evolutionary optimization just for your entire audience or for a segment, you can do that now. With auto-segmentation, you wouldn't say, here are my customer segments. You'd say, here are the variables I want you to consider about segmentation, right? Where did they come from? What's the time of day where they are? What's the weather where they are? What did they buy last time? Are they in fact an existing customer? And what Ascend evolves then is the neural network that connects these inputs between all those things you wanted to test on the design side, these headlines, these layouts, these whatnot. So, in plain English, when you've run one of these experiments, at the end of it, for every individual that comes in, based on their input characteristics, they're going to see an optimized version of the design that's best suited to allow them to convert. And these concepts are not limited to design concepts. Purely, we're also starting to use those for recommendations. So if you think about what guides what's important in terms of someone's selection of a product, in this case, a fashion product, is it the look and features of that product? Is it the colors of that product? Is it the brand? Is it the price? Is there a value for just having lots of different types of products? So the combination of evolution and deep learning is going to allow us to usher in an era of truly personalized, massively multivariate optimizations, and it's going to change a lot about how we work. And our goal as a company is to ultimately start to do that kind of optimization at the ad level and then take it all the way down to the landing page. So from ad to landing page, a single optimization based on the individual, looking at dozens of potential different variables for creating that specific design. So it's pretty exciting stuff. We're really great about it. It's worth thinking about how you approach testing and how much your approach to what to test, because I see it in the speeches here, is based on your use of A/B testing, where you can only test one thing at a time. And we saw it yesterday. A lot of people don't want to test the small stuff. You want to focus on big, high-impact changes. That's perfectly sensible when you can only test one thing at a time. But using evolution, there's a chance to sort of approach things differently. To not get stuck on that near hill and only optimize until you need that redesign, but to throw everything in together and to allow you to test many more ideas much more quickly and be much more exploratory in what you test. Right? So the first advantage, of course, is better results faster. When you can test 10 or 20 or 30 ideas at once, as opposed to one or two, the ideas can be the same. You're just going to do better. There's more of them. You'll process them faster. By automating the process, right? Because the benefits of the AI here are, the big one is the acceleration of the experimentation, but the second one is the automation. By handling the automation of the production tasks, you allow your team to spend your time on analysis, on strategy, on the thinking, on the stuff that really is going to move the needle and make your testing programs more effective, right? When you can test more things all at once, you can afford to be more creative. You can take more risks. You can be more granular, or you can be more expansive. There's many ways to use increased capacity, and that's a question I'd want to leave you with is, what would you test and how would your testing change if you could test 20 or 30 things per experiment? And then finally, one of the nice things we see about this approach is it allows us to democratize, right? We hear a lot about being data-driven, but here in these rooms we complain a lot about hippos, because the simple reality is if you can only test one thing, someone has to decide what that's going to be. And when you have a testing system that allows you, for the first time, to really do big multivariate testing without requiring tons of traffic, it can change how you think organizationally and allow you to draw in the inputs and the ideas from more people in your team that, in a way that can only be powerful. So just in a closing thought, before we take any questions, this was a quote from Kevin Kelly. It's not a race against the machines, right? If you race against the machines, you'll lose. It's a race with the machines, right? And he goes on to say that those will be paid in the future based on our ability to work with, how well we work with artificial intelligence. But as professional, conversion optimizers and growth hackers look at your world and your technology, it's important to stay aware. Be aware that new things are happening. We're one of the exciting AI players in conversion optimization. There's some other interesting things happening. And it will open up a new world to you that will allow you and your teams to be more effective in your organizations, achieve goals faster in a way that will also allow you to do what you love best, the thinking and the strategy, and get rid of the manual tasks that machines can do better. And with that, thank you very much.